Counters change their accumulated value when the rung goes from false to true, and will not change the accumulated value again until the rung goes false and then true again. There are two types of counter instructions, the CTU or count up instruction and the CTD or count down instruction. When the CTU goes from false to true, the accumulated value is incremented by 1. When the CTD instruction goes from false to true, the accumulated value is decremented by 1. You must define the counter by creating a tag before entering the preset value. A RES, or reset instruction, is typically used to reset the counter's accumulated value to 0. Counters are retentive in that the accumulated values and the status bits are retained even during a power interruption. Two items of data associated with the counter are the PRE, or preset value, and the accumulated value, or ACC. These are both double integer values. There is a CU, or count up enable bit, that is true whenever the CTU instruction is true. There is also a CD, or count down enable bit, which is true whenever the CTD instruction is true. The done bit, or DN, is true when the accumulated value is equal to or greater than the preset value. The overflow bit, or OV, is set if the accumulated value is incremented past the maximum positive value for a 32-bit signed integer. The underflow bit, or UN, is set if the accumulated value is decremented past the maximum negative value of a 32-bit signed integer. After you place the CTU or CTD instruction in your ladder logic program, right-click on the question mark and select New Tag. Enter a descriptive tag name, an optional description, choose the scope of the tag, and then click OK. In this program, we will use an up counter to monitor when 24 bottles have passed the bottle sensor. Each time a bottle passes, the CU bit will turn on the increment pilot light. After 24 bottles have passed, the preset reached pilot light will be turned on. We will simulate the bottles passing by closing switch 1 on the slot 1 input. When the accumulated value reaches 24, the done bit is true and preset reached pilot light turned on. Unlike timers, counters can exceed their preset values. The reset button will reset all values to 0. In this conveyor program, we are using two count up counter instructions. Both counters will be incremented whenever a container passes the container sensor limit switch. When the 6th container activates the limit switch, the container counter counts done bit will be true, which will enable the solenoid to extend and divert that container. As soon as the container is moved away from the container sensor limit switch, the solenoid will be de-energized and retract. The next 6 containers will be diverted as they reach the container sensor. After 11 total containers have passed, the second counter's done bit will be true, and both counters will be reset and the process will start over. Follow the operation of the counters. Since the container sensor is true when the reset instruction is executed, both counters will be incremented on the next scan. The count-down counter, or CTD instruction, decrements the accumulated value on every false to true transition of the instruction. The CTD instruction is often paired with the CTU instruction by using the same tag name to create an up-down counter. In this program, we have two counter instructions. CTU and CTD address to the same timer tag, counter_1. The enter limit switch will cause the accumulated value to increase by 1, and the exit limit switch will cause the accumulated value to be decreased by 1. When 50 more items have entered than have exited, the done bit will become true, turning off the conveyor contactor. At this point, 40 more items have entered than have exited. In this program, we use a counter and a timer to determine the rate of bottles passing a sensor. When the start switch is pushed, the timer starts timing for 1 minute while all of the conditions on the rung become true except for the bottle sensor. Every time the bottle sensor goes from false to true, the counter will increment the count. After 1 minute, the rung will be false because the done bit of the timer is true, and the accumulated value will be the number of bottles per minute passing the sensor. In the simulation, the timer is only set for 30 seconds. After closing the start switch, we will close the bottle sensor switch to simulate bottles passing the sensor. Closures of the bottle sensor switch after the timer done bit is a 1 are not counted. The rate would be 37 bottles per 30 seconds, or 74 bottles per minute.